Okay, yeah, so this is just a very quick overview, 5 minutes, of an automated demand forecasting model for new railway stations that I developed as part of my PhD, and it was then implemented on DAFNI as part of an impact acceleration account project. And it was one of the pilot projects on DAFNI. So the model itself is intended to forecast demand for new local stations. So they're stations that are in categories E and F, and typically have less than 250,000 entries and exits per year. And the model is able to forecast demand for individual stations, an entire line. It's also able to examine potential abstraction from existing stations. So that's where a new station will draw customers from an existing station. So it allows you to analyze how much of the expected demand at a new station is actually new demand, rather than just displacing demand from somewhere else. And the model also allows you to do some visualization, including looking at station catchments. The actual model that's sort of underpinning all of this is a trip end model. And it estimates the number of entries and exits per year, and that's assumed to be a function of the catchment population and a range of service and facility variables. And a novel sort of aspect of this work was how the station catchments were defined, and they're probability-based catchments, and they're defined or built up from the postcode level. So essentially each postcode has a number of potential alternative stations assigned to it, and using a station choice model, the probability of each of those stations being chosen by someone who is going to travel by rail from that postcode is calculated. And that probability is used to weight the population of the postcode as an input to the model. And then the range of other predictive variables are things like service frequency, the number of jobs in the vicinity of the station, and the number of car parking spaces, that type of thing. So as I said, this was implemented as a pilot project. And so what you see here is how it looked as part of that pilot project. So this looks slightly different from sort of stuff Tom was showing you earlier, because it hasn't yet been fully integrated into the current DAFNI system. But this just shows an example of the input screen for setting up the details for each station. So you can build up this information for one or more stations, which, as I say, could be individual stations, or they could be treated as if they're all existing at the same time as part of a new line. Also, as part of this sort of web application that we had, there was an interactive map that enabled you to select where the station was going to be located, and also find out information about existing stations and populations and postcodes. It had a job submission management area where you could assign the number of CPU cores to be used by the model, and also the facility to upload and download the configuration file, as there's quite a lot of configuration steps involved in setting up this model. The ability to actually export that and edit it outside of the platform was quite important. And also, because each of these jobs can take quite a while to perform, depending on the complexity, so it can be several hours or even into more than one day, You've got the facility to look at the jobs and how they're progressing and access a history of jobs. And along with that was a detailed log file. So you could actually identify any errors or any problems with the model as it progressed. And this is just an example of one of the visualizations from the model. This is showing a station catchment for a fictional proposed new station in Helston in Cornwall. And this basically shows what is possible from using the station choice model and the probability-based catchment. And this is showing for every postcode in that area, what's the probability of this new station at Helston being chosen, with the dark colours, the reds, showing a probability up towards 1. So just to summarise really, the main benefit that we've sort of got from having this on DAFNI is really it's enabled the rapid and effective sharing of the model. It's very easy for things like this that are developed as part of a PhD project, in my case, just become another siloed model where only, you know, 1 or 2 people possibly know what it is and how to use it. As a result, it's been accessible to students and other researchers, so the model has been used for a variety of work, including the Oxford-Cambridge Arc that Aidan was talking about. It's also been used by master's students as part of their projects. As has already been mentioned, there's potential to link this directly to other DAFNI models. And really it's maximised the ability, the knowledge exchange and research impact of this piece of work. And it's been particularly useful for demonstrating the tool. So we've done quite a bit of outreach work with the rail industry, and it's really been a good way to actually illustrate the model and how it works.